October 2025. The European Southern Observatory makes an announcement. They've found a rogue planet eating 6 billion tons of gas every second. No star, no sun, nothing to orbit, just a world feeding alone in the dark. Chai 1107-7626. 620 light-years away, 5 to 10 times the mass of Jupiter. And between May and August, its light grew 8-fold. 3 anomalies, each one breaking the rules of planetary physics. What could make a planet glow that bright without a star? ESO's Very Large Telescope recorded hydrogen emission lines at 656 nanometers, the same spectral fingerprint we see in stars devouring gas. Imagine a blowtorch igniting in the vacuum of space. Then JWST looked deeper into the mid-infrared, water vapor bands, a hot continuum glow. The signature of an accretion disk, except this one surrounds an object 10 times smaller than the smallest brown dwarfs. According to ESO's October 2nd press release, the mass inflow rate is about 10 to the -6 Jupiter masses per year, roughly 6 billion tons every second. That number shouldn't exist. Rogue planets are supposed to be cold, their gas long dispersed, their growth long over. Yet Che 1107-7626 keeps feeding, a living planet in exile. How is that even possible? Here's where the equations collapse. Accretion converts gravity into light. From that, we can predict brightness. But this planet shines 100 times brighter than the math allows. Its luminosity is near the Eddington limit, the point where radiation pressure should blow gas away, yet the gas keeps falling in. Johns Hopkins researchers reported an 8-fold outburst, similar to what we see in FU Orionis stars, except those are hundreds of times more massive. Gaia confirmed there's no nearby star, no external heat source. Whatever's happening is happening inside the planet disk system itself. Stop and think about that. A world the size of Jupiter, growing 100 times faster than physics says it can, completely alone. So what launched this monster? Three ideas dominate the debate. Theory 1, ejection with disk retention. The planet once orbited a star in a crowded nursery. A violent encounter flung it into interstellar space, but somehow it kept its disk. Those same encounters usually strip disks away within a few thousand years. Finding one still feeding a million years later is statistically impossible. Theory 2, direct gravitational collapse. It never had a star. It formed directly from a collapsing clump of gas, a miniature star that never lit. That fits the isolation, but the conditions required, ultra-cold, ultra-dense pockets of gas, are rarely seen. Theory 3, binary fragmentation. Maybe it was part of a young binary. One fragment became a star, the other, this rogue planet, broke free, taking a piece of its birth envelope with it. It would explain the mass and the leftover disk. Each scenario solves one mystery, but none explain the 8-fold flare, which means we're missing something. Most astronomers now favor a hybrid explanation. Super Eddington accretion with radiation beaming. Picture a thick, glowing torus around the planet. Light escapes through narrow cones above the poles, while gas keeps falling in along the equator. Globally, the brightness looks impossible. Locally, it works, like a lighthouse shining through fog, blinding in one direction, dim in another. That would let a planet eat far faster than theory predicts, but it demands extreme conditions. Magnetic fields thousands of times stronger than Jupiter's, rotation in mere hours, and disk temperatures rivaling a red dwarf's surface. Science Alert suggested another layer, episodic infall. If the disk holds 10 Jupiters worth of gas, its own gravity could trigger spiral collapses, cosmic avalanches feeding the planet in bursts. We're watching a process that blurs the line between planet formation and star formation. It doesn't fit our boxes. It never did. So let's return to the three anomalies. First, the accretion rate, 100 times too high, explained by beamed radiation or episodic collapse. Second, the heat, thousands of degrees without a sun, explained by magnetic funneling or shock heating. Third, its solitude, no star, no companion, explained by direct collapse or a broken binary. Each theory holds a piece. None complete the puzzle. In 2026, JWST will monitor this planet for months, searching for repeating flares or chaotic bursts. ALMA will weigh the disk. The extremely large telescope will try to image the accretion columns directly. As Dr. Nuria Alves de Oliveira said in the Johns Hopkins Hub, this discovery forces us to reconsider whether formation pathway, not just mass, should define what we call a planet. Che 11 OC 7626 refuses to fit our definitions. It's the missing link between planets and stars, proof that even in the darkness between suns, the universe still builds giants. JWST begins dedicated observations in spring 2026. Over 10,000 astronomers are watching this one world. ESO calls it the most significant planetary discovery of 2025. Subscribe to follow the data, because the next time the universe breaks its own rules, you'll want to see it happen. In Cosmos, we trust.